Current. What is it and how does it work? Well, when you first think of current, you might be reminded of the flow of water, which acts similarly to the flow of electrical current, and it's where its name originated. Current is the flow of charged particles through a conducting material, such as a wire. In relation to electricity, the charged particles are known as electrons. The common symbol for current is the capital letter I. The standard unit is ampere, amp, symbolized by the letter A. 1 amp of current represents the flow of 1 coulomb of electrical charge in 1 second. I equals QT. Atoms in a conducting material have lots of free electrons, which are able to move from atom to atom randomly, with no particular flow. However, when a voltage is applied and a potential difference occurs, the electrons all move in the same direction, resulting in current. The transfer of energy that happens with the flow of current is almost instantaneous from the moment power is given to a circuit. This is due to the electrons in the current all pushing on one another. For example, if you look at the electrons as the blue circles and the encasing lines as the wire, you can see that as you add a circle, one comes out the other end, even though the individual circle has not moved very far at all. These are the most important and basic formulas for current. Firstly, as mentioned earlier, this is Coulomb's law. Next, we have Ohm's law, and finally, the power equation. These equations are imperative to understanding and working with current and are used every day in the simplest and most complex circuits. There are two types of current, direct and alternating current. The flow of direct current DC only travels in one direction, therefore the current must move from positive to the negative terminal of the battery in a circuit, which is known as conventional current. However, since the electrons are negatively charged, they move from the negative terminal of the battery to the positive, known as the electron flow. The direction the current flows does not make a difference as long as it's kept uniform for the circuit. The output wave function generated by a DC current will always be a straight positive line since there is little to no variation in current. The flow of alternating current AC, as the name suggests, alternates, meaning the current and the direction of the flow of electrons changes many times a second. In Australia, the standard frequency this change of direction occurs is 50 Hz, 50 times a second. The output wave function for an AC circuit will be some variation of a sine wave, as the output varies due to the constant change in current. Here is an example using the equations discussed earlier. Find A, the power output from this circuit, and B, the value of resistor A if 1 coulomb of charge passes through the circuit per second. Firstly, we need to find the current. We can do this by the formula I equals QT, and that's how we get current equals 0.18. Next, to find the power, we use P equals VI, which gives us power equals 10 times 0.1, giving us 1 watt. Lastly, to find resistor A, we first need to determine the total resistance, using Ohm's law, V equals IR. Rearrange this to find R equals V on I, giving us R equals 100. Then, using your knowledge of how resistors are added in series and parallel circuits, we generate this equation, and then solve for A. Finally, we get A equals 85 ohms. Now you have a good understanding of how current works.